the chemistry in everyday life. So we already know that the chemical compounds are employed in a large number of useful work in our daily life, right from the sugar to the soap. We utilize chemicals, right? So a number of chemicals find application in a large sector. The sectors such as the agriculture, in medicines, in the textiles. Correct. So there are n number of sectors where we use chemicals. But in this particular chapter, we are going to deal with the use of the chemicals, especially in the three important sectors. Those are in the medicine, in the food materials, and of course, in the cleansing agents. Right? So, now as we start over with this, let us first deal as how these particular chemicals are used in medicines. In the medicines, we call them as either as drugs or medicines itself, right? So these particular drugs, what are exactly the drugs? How do we define them? So the drugs are usually that of the natural or the synthetic origin. Remember this? These are either the natural or the synthetic origin, which are used for the treatment of disease and which are used for reducing the pain, the suffering from that disease. So these particular chemical compounds, we call them as the drugs or medicine itself. So therefore, the branch of chemistry, or you can say as a branch of science which deals with the use of these medicines in order to treat the disease, is called as chemotherapy. Remember the term, this is called as the chemotherapy. Right? So the chemotherapy is a branch of science which deals with the utilization of medicines in order to treat the disease. While when we are speaking about the medicines, these medicines are usually nothing more than the chemical compounds, but not all the chemical compounds are going to be used as the medicines, right? So these chemical compounds, as what we have, these should have certain properties, as these should be non-toxic. Okay, these should be non-additive. So I can say that the chemical compounds which are non-toxic, which are used in the treatment of disease, are, which should be the non-addictive, are called as the medicines. For example, let us take into consideration of the two things over here. One is penicillin. All right. And the second one is heroin. Now, if we take into consideration of penicillin, the penicillin is an antibiotic in its nature. Okay, while when we consider the heroin is actually a painkiller. But the major difference is that these penicillin, what we have, okay, the penicillin is non-addictive in nature, while heroin causes a high chances. There are a high chances of addiction. Right? So therefore, we do not utilize heroin as a medicine, but rather we prefer penicillin as a medicine. Right? So let's observe one by one. First, its introduction. So the medicines and or drugs, these are nothing more than the chemical substances that of the natural or the synthetic origin, which are used for the treatment of disease, and also used for reducing the suffering from the pain, are called as the medicines or drugs. So therefore, the branch of science which deals with the treatment of disease using suitable chemicals are called as the chemotherapy. In 1910, Paul Ehrlich introduced organic arsenic compound, which is called as a sulfurson. This particular compound was used against the sexually transmitted disease, which is called as a syphilis. Later, he got the Nobel Prize for his work. Now, usually there is no distinction between the drugs and medicine in science. All these medicines are drugs and all the drugs are medicines. Okay, so medicines are the chemical compounds which are used to cure diseases, and there is no toxicity, as we have already discussed, and does not cause any addiction, right? So this is the thing what we have already completed so far. Let's observe the next part of it, and that is going to be how do we classify these particular drugs. So eventually the drugs are classified into 4 different classes, depending upon the first one, depending upon the pharmacological effect. In the second case, we classify these particular drugs on the basis of what is the action that it induces, that is the drug action. In the third case, we have the chemical structures of these particular drugs. So on the basis of the chemical structures, we are going to classify those drugs. And the fourth one, of course, what we have is going to be as on the basis of the molecular targets. Okay, so let's deal with all of these one by one. So in the classification of drugs, drugs can be mainly classified on the basis of first one, pharmacological effects. Now, when do we call it as a pharmacological effects? Now, let's consider that we have certain amount of drugs. And in these particular cases, if all these particular 3 drugs are going to show me only one type of pharmacological effect, and that is if all of these are acting as a, let's say, painkillers. Okay, if all these particular drugs are acting as painkillers, then we would classify all of these 3 into analgesics. Right? Now, on the other hand, let's say that we have certain more compounds over here, which are drugs actually, and let's say these particular drugs are stopping the growth of microorganisms, or let's say they are directly killing the growth. Okay, the growth of microorganism. So these particular drugs, as what we have, these drugs, we classify them under the antiseptics. So depending upon what is the pharmacological effect that particular drug is going to cause, right? Depending upon that, we classify them under different categories, such as the analgesics, antiseptics, and all. So in this type of classification, it is based on the pharmacological effects that has been induced by the drugs. For example, analgesics we have as the pain-killing effect, whereas the antiseptic kills the growth of the microorganisms, right? So the next one is on the basis of the drug action. So the drugs over here, what we have is if these particular drugs have the similar actions, if the particular type of the drugs are going to exhibit similar actions. Okay, because these particular drugs usually react on the biochemical processes. Okay, they have the direct effect on the biochemical processes. For example, if there are certain drugs, let's say these are certain drugs, and all of these drugs are going to react, okay, are going to react by inhibiting. These are reacting by inhibiting the action of histamine. Okay, now this histamine is actually responsible for the inflammation of body parts. Okay, so therefore, if these particular drugs are directly attacking the histamine, okay, this particular enzyme, so therefore what is happening is it is directly reducing the inflammation of the body. So these all these particular drugs which are having the same course of action, that is all of them are acting on histamine. So such kind of drugs, we call them as antihistamine. Okay, so what we have is the next part over here. So in this particular drug action, it is based on the action of a drug on a particular biochemical process. For example, antihistamines. These are the group of drugs which are going to inhibit the action of histamine. So actually the histamine is one which is going to cause the inflammation of the body parts, correct? So therefore, these drugs are acting as antihistamines. So they directly act on the histamine and they reduce the inflammation. So all these drugs, we call them, okay, all these drugs are classified on the basis of their drug action, right? So next one. So in the next category that we would see that on the basis of the structures, correct, on the basis of the chemical structure. Let us say that we have several drugs, and all of these several drugs, let us say that they have a common structure, something like this. Okay, now this is called as sulfonamide. Okay, so these are the sulfonamides. So all the drugs which are having almost similar structure, some derivations over here, some particular alkyl systems may be attached over here, or here there are different alkyl systems which are attached. Okay, so if the drugs are having similar structure as these, we call these particular section of compounds over here in this particular case as sulfonamides. Right? So these are our sulfonamides. So in short, the drugs, the group of drugs which share the common chemical structure. So depending upon that, we classify under the different categories in this case. So therefore, for example, it is based on the chemical structure of the drug, and the drugs are classified in a way when they share a common structural feature. If they have a common structural feature, again, they will be having almost same type of effect. Okay, pharmacological effect, you can say. So therefore, they often have the similar pharmacological activity. For example, sulfonamides. Sulfonamides have the common structural features as we have seen here. Correct. Let's go with the next one, and that is going to be the molecular targets. Now, usually what happens is the drugs interact with the biomolecules. Now, they interact with the biomolecules such as what we have. First one, we have lipids. Let's start with the lipids. We have proteins. We have the nucleic acid. Correct. Now, all of these are nothing more than macromolecules. Now, macromolecules are actually very, very essential. And these particular, whatever the drugs that we have, they usually target these big molecules because these big molecules are usually accompanying biochemical processes. So therefore, these molecules, as whatever we have spoken about, the carbohydrates, let's take the carbohydrates. Okay, we have the proteins, we have the lipids, right, the nucleic acids. Now, all of these, as what we have, okay, these are considered as the molecular targets. Okay, or you can also call it as the target molecule. Now, here is where these drugs are going to come and attack, right? Now, So the drugs usually interact with the biomolecules such as the carbohydrates, lipids, proteins, and nucleic acids. These are termed as the target molecules or drug targets. So the drugs which possess common structure, as we have already discussed in the previous case itself, okay, the drugs which possess some common features, okay, may have the same type of mechanism on the targets. So therefore, the classification, now this is very, very important for the medicinal chemists. The classification based on the molecular target is one of the most important or useful classification for the medicinal chemists. Okay, that is very, very important for us. So the next one is the drug target interactions. Now, in the drug target interaction, first we need to understand about the macromolecules. So as I already said about the macromolecules, so the macromolecules are nothing more than the molecules such as what we have is the carbohydrates. Correct. We have the carbohydrates, we have the lipids, we have the proteins. Correct. And we have the nucleic acids. Right? Now, all of these particular things, what they consider them as the target molecules. Correct. Now, these target molecules as what we have, these are, okay, these target molecules or what we can call it as macromolecules, these are responsible for performing various activities in the body. Okay, so therefore, this perform various activities. Right? Now, for example, if I take into consideration of proteins, okay, so these proteins as what we have, these perform various activities such as, very important, the first one, as such as it catalyzes biochemical reactions. Correct. Second one, at the same time, it acts as the chemical regulators. So chemical regulators are nothing more than I could say as it is acting as hormones. Okay, so it can act as, it can go for the catalysis of biochemical reaction. It is acting as a chemical regulator, and that is nothing more than it's acting as a hormone. It is also involved, these particular proteins are also involved in transferring the genetic material from the parent to the offsprings. Correct. So in transferring genetic material. Okay, it does not end up over here. It also helps, this particular protein also helps in transferring polar molecules. Okay, it also helps in transferring the polar molecules across the cell membrane. Okay, so therefore, these are the things about the macromolecules what one should understand. So therefore, macromolecules such as the proteins, carbohydrates, lipids, nucleic acids are the target molecules, which we have already seen so far. These are the target molecules. Target molecules in a sense, upon these, the drugs are going to interact with. Okay, these macromolecules perform specific functions in the body. For example, proteins perform various functions in the body. The proteins catalyzes biochemical reaction, which we have already known, and hence these are called as enzymes. The protein acts as a chemical regulator, and hence these are called as the hormones. The proteins carry polar molecule across the cell membrane. These carry genetic, the nucleic acid also carry the genetic material from the parent to the offsprings. Correct. So the lipids are the structural part of the cell membrane. Okay, the lipids and the carbohydrates are the structural part of the cell membrane. This is what we have already studied so far. Now, in order to understand how does the drug and the target are going to interact, we need to first understand the catalytic action of the enzymes. So here, this particular enzymes performs in two major ways. Or you can say that these enzymes, as what we have, these enzymes are going to have, these are going to perform two major functions. Okay, so the first function, what these particular enzymes do, is that these enzymes are going to have a specific shape. And these enzymes hold the substrate in a proper position in order to see that the reagents can come and they can react. Okay, and this particular thing can initiate the biochemical reaction. So our first thing that we need to understand is that the first function is it to hold the substrate. Okay, it holds the substrate for the chemical reaction. Okay, now in this particular case, what is going to happen is that the enzymes that we have, these enzymes have a particular shape. Let's say this is our enzyme over here. Okay, let's say this is our enzyme, and this particular shape over here, what we see, this particular groove is nothing more than an active site. Okay, so in this particular active site, usually our substrate having complementary shape comes and fits inside this. Okay, the substrate comes and fits inside. As a result of which there is an interaction between these two. So the enzyme holds that particular substrate in a proper way. After which there is going to be attack. It is going to be attacked by a suitable reagent. It is going to be attacked by a suitable reagent and the reaction takes place effectively. Okay, now here where what we see is the attachment of the substrate and the enzymes. This attachment is usually due to the ionic bonding. Sometimes it may be due to the hydrogen bonding, right? Or sometimes you can also see that it may be due to the van der Waals interactions. Okay, so we have the three parts. Okay, so here, this is the first type or the first way how does the enzyme is going to function. Okay, in the second way, the second function of these enzymes as what we have is to provide this particular enzyme. Okay, this enzyme, what we have, this enzyme provides the functional group. It provides the functional groups which are required, okay, which are required to attack the substrate and to convert that particular substrate so that the entire biochemical reaction can be proceeded. Okay, so it provides the functional group in order to see that the biochemical reaction, what we have, this reaction proceeds. Right? So let's observe this entire scenario now. So the enzyme usually performs two functions. In the first case, the function of the enzyme is to hold that particular substrate, okay, for the chemical reaction. The active sites, we have already seen about the active sites. The active sites of the enzymes hold the substrate molecule in a suitable position so that it can be attacked by a suitable reagent very effectively. The substrate will bind to the active sites of the enzyme through a variety of interactions. We have already seen about the interactions such as the ionic bond, the hydrogen bonding, or the van der Waals interaction, or in some cases a dipole-dipole interaction can also be seen. Right? So let's go further. So the second function of the enzyme is to provide the functional groups which can attack the substrate and carry out the entire chemical reaction. right? So this is what I was speaking about. Let's consider this as an enzyme over here, and this particular groove that we can see, this groove is our active site, right? This is a substrate which will fix over here, something like this. Okay, so this section, we call it as the enzyme substrate complex, right? So let's proceed further. So in the next case, what we need to study is the drug enzyme interactions. That is, how does an enzyme interact with the drugs? So therefore, drugs usually interact with the enzyme in order to inhibit the enzyme actions. So what is the first rule that we need to understand here is the drugs will interact with the enzyme in order to inhibit the function of enzyme, right? So how does this particular drug is going to inhibit? This is what it is going to do, but how it is going to inhibit? So it usually inhibits this function of enzyme by blocking. It is going to block the active sites. Okay, it usually blocks the active sites. Thus, what it is going to do is it is going to prevent the substrate, okay, from getting attached. All right, so it prevents. So once it is blocking the active sites, it prevents the particular substrate from attaching. So in short, we can say that it's just not preventing the substrate from attaching, rather it is also indirectly inhibiting the enzyme activity. So it inhibits the enzyme activity, right? This is how the things are going to work. So such kind of drugs which are going to inhibit the activity of enzyme, we call them as the enzyme inhibitors, right? So this is the enzyme inhibitors. So let's observe one by one into detail of this. So the drugs inhibit any of the above mentioned activities of enzyme. This can block the binding site of enzyme and prevent the binding of the substrate, or can inhibit the catalytic activity of enzyme. So such kind of enzymes, we call it as the enzyme, such kind of drugs, we call them as the enzyme inhibitors. Very important, right? So let's go with the first one. So how does it do that? So here, usually what happens is the drugs, what we have, it can compete with the substrate while it is getting attached. Okay, so if there is an enzyme, let's consider that there is a particular enzyme over here, right? Let's say this is our enzyme. Now, if there is, this is our drug, and over here is our substrate, the natural substrate. Now, what does this particular thing will do is it will enter into the competition. It competes with the substrate and it will try to fit in this particular active site as soon as possible. Once it fits into this, what it is doing, it is inhibiting the catalytic activity of the enzyme, because it is not going to see that this particular drug is going to be metabolized. Okay, it is not going to further break down the substrate, because substrate is not entering into the active site of the enzyme. Thus, the drugs inhibit the attachment of the substrate on the active walls of the enzyme in two ways. What is the first way that we have seen? Wherein the enzymes are competing with the substrate molecule. So drugs compete with the natural substrate for their attachment on the active sites of the enzyme. Such drugs, we call them as the competitive inhibitors. Very important point to note. Okay. In the second case, what happens is usually in the second case, these particular drugs do not act on the active sites. So let's consider that this is our enzyme over here. Let's consider this is the enzyme. Okay, let's say this is the enzyme with the active sites. So what does this particular drug will do now is, instead of acting at the active sites, this particular enzyme will act at the regions away or other than the active sites. Okay, so when it reacts at the regions away from the active sites, it will change the shape of this particular active site group. Okay, due to which whatever the substrate that we have, it will not fit into this particular active site, because our enzyme is acting at a particular site which is blocking this active site. Okay, because of the shape of this particular drug, what is going to happen is the active site gets blocked. Now, such kind of sites wherein the drug is acting on the enzyme, we call it as allosteric site. Okay, so these are the allosteric sites over here. So as a result of this, the binding of the drug at the allosteric site takes place, and the shape of the active site is going to change. As the shape of that particular active site changes, the substrate is unable to fit into the active site, right? It does not even recognize that particular active site. And therefore, if this particular bond between the enzyme and the drug, if this particular bond, in case if it is a covalent bond, okay, in case if this particular bond is a covalent bond, then it cannot be broken. This particular enzyme becomes blocked permanently. It becomes locked permanently. Okay, as it becomes blocked permanently, what's going to happen then is that this particular enzymes will be degraded by the body, and the body synthesizes new enzyme again, right? So therefore, let's observe this condition. So some of the drugs do not bind to the enzyme's active site. These bind to the sites which are different than the active sites, and these particular sites we call them as allosteric sites. This binding of the inhibitor to the allosteric site is going to change the shape of the active site in such a way that the substrate cannot recognize it. So if in the case if the bond between the drug and the enzyme inhibitor is going to be a covalent over here, then finished. Then that particular enzyme that we have is blocked permanently, right? Then what body is going to do? The body cannot utilize that particular enzyme anymore because it is useless, right? So hence what it does is this body is going to degrade that enzyme. Okay, as it degrades that enzymes, and then further it is going to synthesize a new one, right? So this is how the reaction occurs. So this is the enzyme and this is the active site over here, right? So what happens is the drug is going to come, and the drug, what it does is it is going to react, correct? So in this particular case, we have shown the first condition wherein the drug is competing against the substrate. So here, the drug is coming and it is fixing itself into the active surface over here. Okay, as a result of which the substrate is left behind. Okay, so this is the first case, and that is the competitive inhibitors. This is for the competitive inhibitors here, right? So next one, what we have is the receptors as the drug target. First, we need to understand what exactly are these receptors. Now, whenever we see the cell membrane, okay, let's consider that this particular thing is the cell membrane here. Okay, in the cell membrane, usually what happens is there are certain protein molecules, big protein molecules, which we call it as the receptors. These protein molecules are usually embedded into this cell membrane like this, but it usually projects out. It usually projects out and it has an opening system over here like this. So same is at the bottom side, something like this. These particular molecules which projects out over here, these molecules have an opening over here, as well as at the same time it has some active sites. So there are active sites here. Okay, so as a result of which, what is going to happen is whenever we have the molecules. Okay, now in this particular case, if there is a particular information that has to be passed over. Okay, what happens is between the two neurons or between the neuron and the muscle, if there is a message that has to be passed, these are passed by the help of the chemical. And these particular chemicals which passes the message, we call it as the chemical messenger. Okay, we call them as the chemical messengers. So what does this chemical messengers do? These chemical messengers will come near these active sites. As they come near the active sites, they have a particular proper shape. Okay, they come in, they interact, they leave the particular message or the chemical into this, as this particular message is passing from the outside to the cell, inside the cell, you can say, right? Now, as soon as this particular chemical messenger comes, the active site shape is going to change. The shape changes. Okay, how does the shape changes? This shape becomes as the complementary shape as that of the chemical messenger, right? So as a result of which it comes, it attaches itself to the active sites on the receptors and it passes down the message. As the message is passed down, again this particular chemical messenger is going to leave away. Okay, so these are called as the receptors, right? So the receptors are actually the protein molecules which are crucial for the body's communication. Majority of these are embedded in the cell membrane, as what we have already seen. The receptor proteins are embedded in the cell membrane in such a way that a small part of them which have the active site is going to project out of the cell membrane and they are going to go outside the cell region. Correct. So therefore, this is how it looks like. Okay, so this is a cell membrane. Over here, what we have is this is the receptor protein. This is a binding site, as we were speaking about. It has a particular shape. Shape keeps on changing depending upon the receptor. Okay, but again, it is very, very specific. There are n number of receptors. There are n number of chemical messengers, but every single receptor is very specific in its work. Okay, so therefore, so as we have already seen in the body, the message between the two neurons or between the neuron and the muscle is communicated through certain chemicals, and these chemicals we call them as the chemical messengers, okay, which are received at the binding site of receptors, which we have already seen. To accommodate this particular messenger, the shape of receptors is going to change. This is what we have seen, correct? So this brings about the transfer of the message into the cell, and the chemical messenger gives the message to the cell without entering into the cell. This is how it happens. So we have seen this chemical messenger coming inside. It will come, it will interact with this particular binding site. The shape of this changes. If you see here, the shape has changed. Correct. It drops the message has come over here, and after dropping the message, this chemical messenger is going to go away. Correct. So this is how the receptors work. Now we need to understand as what this has to do with the drugs. Correct. So when you observe about the drugs, as I already said, that there are large number of receptors in the body that interacts with the different chemical messengers. These receptors show selectivity. That means these are very, very specific in their work, okay, for one chemical messenger or the other, because of their binding sites have different shape, structure, and amino acid composition, right? So now you need to understand this part here. So the drugs bind to the receptor. So where it is binding, the drug is coming, and if it is binding to the receptor, okay, it is inhibiting its natural function. So these particular drugs, we call it as antagonists. So once this drug is going to come and bind to that receptor, what happens is the messages cannot be passed because the actual messengers are not coming and they are not getting attached to those receptors. Okay, so this is done when we do not want the messages to be passed into the cell. Okay, so in short, what we have over here, these are useful when the blocking of message is required. And there are other type of drugs which mimic, okay, they are going to just mimic the natural messengers. They are going to show as they are the natural messengers. They will come and they will attach to those particular receptor sites, and these kind of drugs are very useful when the body of that particular human is lacking the natural chemical messengers. Okay, so such kind of things we call it as antagonists. So two things are very important. If the drug is coming and inhibiting the natural functions, then we call it as the antagonists. Okay, on the other hand, if the particular thing, that is the drug, is coming and if it is just mimicking the natural messengers, because there is no messenger which is present in that particular body, in such case that particular drug, we call it as agonists. Okay, so these are the two things what we need to know. So I hope you people have understood all these particular phenomena. To take care, thank you for watching.